The death of the central router. Stanford's MoE-Mesh has reduced the routing overhead of mixture of experts models to near zero by eliminating the central gatekeeper entirely. This lattice-based approach moves tokens across the GPU cluster using peer-to-peer gossip, rather than waiting for a central router to rank experts. In the paper released last week, researchers demonstrated that this architectural shift maintains accuracy while cutting total inference latency by 35% on models with over 100 billion parameters. The gossip protocol mechanism. In standard mixture of experts, every token must pass through a top K gating function to decide which expert handles the computation. This creates a serial bottleneck and often leads to load imbalance where some GPUs sit idle. MoE-Mesh replaces this with a distributed lattice where each expert node only communicates with its immediate hardware neighbors. Tokens navigate the cluster like water finding its way through a physical mesh, moving toward high-affinity experts based on local gradients rather than a global map. This converts a complex scheduling problem into a parallel transport mechanism that scales linearly with the number of experts. And the hidden cost of this efficiency is the interconnect tax. The interconnect tax. While latency gains are significant, the Stanford benchmarks reveal a constraint I call the interconnect tax. The lattice routing assumes a physical torus or high-bandwidth mesh topology between GPUs. When the team tested MoE-Mesh on standard InfiniBand clusters without optimized cabling, the gossip overhead actually exceeded the original gating time. They observed a 14% throughput degradation in environments where the physical hardware layout did not mirror the model's logical lattice. This proves that for large-scale mixture of experts, software-only solutions have hit a ceiling. Performance gains now depend entirely on hardware-aware expert placement rather than algorithmic tweaks. This shift points directly toward a much larger change in how we build clusters. The signal under the noise. The data from MoE-Mesh suggests we are moving away from the gatekeeper architecture that has dominated transformer design for years. By proving that decentralized routing can match the precision of global gating, this research signals a move toward models where the architecture is a direct reflection of the physical network fabric. As we scale toward trillion parameter densities, the traditional separation between model logic and hardware topology is becoming a liability. For builders, this means the focus of optimization is shifting from better gating functions toward topological alignment. If your expert placement does not account for the physical distance between compute nodes, the decentralized gains of MoE-Mesh will be eaten by cross-rack latency. This is not just a new way to route tokens, it is a requirement for any cluster-scale model that hopes to bypass the memory wall. Watch for the release of the Mesh Kernel 1.2 library in August, which is slated to automate this physical-to-logical mapping for Blackwell systems. Subscribe for more